contains duplicate, explained step-by-step problem. Given an integer array nums, return true if any value appears at least twice in the array. Return false if every element is unique. Example input: nums equals 1, 2, 3, 1. Output: true. Why? 1 appears 2 times. Indexes: nums 0 equals 1. Nums 3 equals 1. So, the answer is true. Simple definition. Contains duplicate means check whether an array has any repeated number. Example: 1, 2, 3, 1. Here, 1 is repeated. So, true. Another example: 1, 2, 3, 4. No repeated values. False. Important rule. The problem asks, does any number appear more than once? It does not ask. Which number is duplicate? It does not ask. How many duplicates exist? It only asks. True or false? Brute force approach idea. Compare every number with every other number. Check nums 0 with nums 1. Check nums 0 with nums 2. Check nums 0 with nums 3. Check nums 1 with nums 2. If any two values are equal, return true. Brute force. Java code. Public boolean contains duplicate. Int nums. 4. Int I equals 0. I less than nums length. I plus plus. For int j equals I plus 1, j equals nums length, j plus plus. If nums I equals nums j, return true. Return false. Brute force dry run. Input: nums equals 1, 2, 3, 1. Check. I equals 0, j equals 1, nums 0 equals 1, nums 1 equals 2. False. Check. I equals 0, j equals 2, nums of 0 equals 1, nums of 2 equals 3. 1 equals 3? False. I equals 0, j equals 3, nums 0 equals 1, nums 3 equals 1, 1 equals 1. Return true. Brute force complexity time O(n) squared space O1. Why O(n) squared? For each number, we compare it with many other numbers. Problem: slow for large arrays. Optimized approach using HashSet main idea. Use a HashSet to store numbers we have already seen. For each number, if number is already in HashSet, means duplicate found, means return true. Otherwise, add number to HashSet. HashSet concept. HashSet stores unique values. Example: scene equals 0. After reading 1. Scene equals 1. After reading 2. Scene equals 1, 2. After reading 3. Scene equals 1, 2, 3. Next value is 1, since 1 already exists. Duplicate found. Return true. Optimized Java code. Import java.util. HashSet. Import java.util. Set. Public class solution. Public boolean contains duplicate. Int m nums. Set integer scene equals new HashSet. For int num dot nums. If scene dot contains num, return true. Scene dot add num, return false. End. Input: nums equals 1, 2, 3, 1. Start. Scene equals iteration 1 num equals 1. Check. Scene contains 1? No. Add. Scene equals 1. Iteration 2 num equals 2. Check. Scene contains 2? No. Add. Scene equals 1, 2. Iteration 3 num equals 3. Check. Scene contains 3? No. Add. Scene equals 1, 2, 3. Iteration 4 num equals 1. Check. Scene contains 1? Yes. Duplicate found. Return. True visual flow nums equals 1, 2, 3, 1. Scene equals. Num equals 1, scene has 1. No add 1, scene equals 1. Num equals 2, scene has 2. No add 2, scene equals 1, 2. Num equals 3, scene has 3. No add 3, scene equals 1, 2, 3. Num equals 1, scene has 1. Yes, return true. Why this works. HashSet does not allow duplicates. So when we see a number for the second time, scene.contains num will return true. That means the array contains duplicate. Optimized complexity, time on, space on, y-on time. We loop through the array once. HashSet lookup is average O1, y-on space. In the worst case, all numbers are unique and stored in the HashSet. Example, 1, 2, 3, 4, 5. HashSet stores 1, 2, 3, 4, 5. Best Java solution. Import java.util.hashset. Import java.util.set. Public class solution. Public boolean contains duplicate int end of nums. Set integer scene equals new HashSet. For int num nums. If scene dot contains num, return true. Scene dot add num, return false. I add debugging version. Use this when learning. Import java.util HashSet. Import java.util set. Public class solution. Public boolean contains duplicate int nums. Set integer scene equals new HashSet. For int num nums. System out println. Current number equals plus num. System out println scene before check equals plus scene. If scene contains num. System out println duplicate found plus num. Return true. Scene dot add num. System dot out dot println scene after add equals plus scene. System out println no duplicate found. Return false. 4. Nums equals 1, 2, 3, 1. Debug output idea. Current number equals 1. Scene before check equals 0. Scene after add. Current number equals 2. Scene before check equals 1. Scene after add equals 1, 2. Current number equals 3. Scene before check equals 1, 2. Scene after add equals 1, 2, 3. Current number equals 1. Scene before check equals 1, 2, 3. Duplicate found. 1. Return. True alternative approach. Sorting idea. Sort the array. Then duplicate numbers will be next to each other. Example. 1, 2, 3, 1. After sorting. 1, 1, 2, 3. Now check adjacent values. 1 equals 1. Return true. Sorting Java code. Import java.util.arrays. Public boolean contains duplicate int nums. Arrays dot sort nums. For int I equals 1, I equals nums length I plus plus. If nums I equals nums I minus 1, that return true. Return false. Sorting complexity time, O n log n, space O1 or O log n, depending on sorting implementation. But note, sorting changes the original array order. HashSet is usually better for this problem. HashSet versus sorting approach, time space notes. Brute force, O(n) squared, O1, simple but slow. Sorting, O(n) log n, low changes array order. HashSet, O(n), O(n), best common solution. Best interview answer. Use HashSet for O(n) time. Common beginner mistake 1. Returning false too early. Bad. For int num nums. If scene dot contains num, return false. Problem. This returns false after checking only the first new number. Correct. For int num times. If scene dot contains num, return true. Scene add num, return false. Common beginner mistake 2, forgetting to add to HashSet. Bad. For int num nums. If scene dot contains num, return true. Return false. Problem. Scene always stays empty. Correct. Scene dot add num. After checking. Common beginner mistake 3, checking after adding. Bad. Scene dot add nom. If scene dot contains num, return true. Problem. After adding num, HashSet will always contain num, so it returns true immediately for the first number. Correct order. If scene dot contains num, return true. Scene dot add open parenthesis num close parenthesis semicolon. Common beginner mistake 4 colon. Thinking HashSet stores indexes. For this problem, we do not need indexes. Use set integer scene equals new HashSet, not map integer scene equals new hashmap. Hashmap is useful for toSum because we need indexes. HashSet is enough for contains duplicate because we only need to know if value appeared before. Common beginner mistake 5, not handling empty array. Input. There is no duplicate. Output. False. The HashSet solution handles this automatically because the loop does not run. Common beginner mistake 6, not handling negative numbers. Input. -1, -2, -3, -1. Output. True. Why? -1 appears twice. HashSet works with negative numbers. Unit test. Import static org.junit.jupyter.api.assertions assert false. Import static org.junit.jupyter.api.assertions assert true. Import org.jnit.jupyter.api.test. Class contains duplicate test. At test, void should return true when duplicate exists. Solution equals new solution. Int n nums 2, 3, 1. Boolean result equals solution.contains duplicate nums. Assert true result. At test, void should return false when all values are unique. Solution equals new solution. Int nums equals 1, 2, 3, 4. Boolean result equals solution.contains duplicate nums. Assert false result. At test, void should return true for negative duplicate. Solution equals new solution. Int end nums equals -1, -2, -3, -1. Boolean result equals solution.contains duplicate nns. Assert true result. At test, void should return false for empty array. Solution equals new solution. Int nums equals : Boolean result equals solution.contains duplicate nums. Assert false result. Interview explanation. Say this: I will use a HashSet to track numbers already seen. I iterate through the array. For each number, I check if it already exists in the set. If it exists, that means we found a duplicate and return true. Otherwise, I add it to the set. If the loop finishes without finding a duplicate, return false. This gives O of n time and O of n space. Interview questions. 1. What is the brute force solution? Compare every pair. Time. O(n squared). Space. O1. 2. What is the optimized solution? Use HashSet. Time. O(n). Space. O(n). 3. Why use HashSet? Because HashSet gives average O1 lookup and stores unique values. 4. What does the HashSet store? It stores numbers already seen. Example. Seen equals 1, 2, 3, 5. When do we return true? When current number already exists in HashSet. If scene contains num, return true. 6. When do we return false? After checking all numbers and finding no duplicate. Return false. 7. Does this work with negative numbers? Yes. HashSet can store negative integers. 8. Does this work with 0? Yes. Example. 0, 1, 0. Output. True, 9. Can sorting solve this? Yes. Sort the array and check adjacent numbers. But sorting takes O(n) log n. HashSet is faster on average. O(n) 10. What is the main difference from toSum? toSum needs indexes, so we use HashMap. Contains duplicate only needs true-false, so we use HashSet. Practice problems similar to contains duplicate. Practice these next. 1. Contains duplicate. 2. Contains duplicate 2. 3. Contains duplicate 3. 4. First unique character in a string. 5. Valid anagram. 6. Intersection of two arrays. 7. toSum. 8. Missing number. 9. Find all duplicates in an array. 10. Set mismatch. 7-day practice plan. Day 1. Learn brute force. Practice. 1, 2, 3, 1. Output. True. Day 2. Learn HashSet solution. Practice. 1, 2, 3, 4. Output. False. Day 3. Practice duplicates at beginning. 5, 5, 1, 2, 3. Output. True. Day 4. Practice duplicates at end. 1, 2, 3, 4, 4. Output. True. Day 5. Practice negative numbers. -1, -2, -3. Output. True. Day 6. Write debug print version. Track. Current number seen before check. Seen after add day 7. Explain the solution like an interview. Use this structure. Approach. Why HashSet, dry run, complexity, edge cases, final summary. Contains duplicate is a beginner-friendly HashSet problem. Important concepts. Caps, array, caps, duplicate, caps, unique values, caps, HashSet, brute force, caps, sorting, caps, time complexity, caps, space complexity, early return, edge cases. Best solution. Use HashSet time, O(n), space, O(n). Key idea. If a number is already in the HashSet, then it is a duplicate. Input. 1, 2, 3, 1. We find 1 appears twice. Output. True.